Okay, this will be a pretty rough recording. I'm just doing it seat of the pants, but what I have here is a calculation using GeoGebra, Geogebra. You can get it from geogebra.org, and it's a free download. The version I'm using here is Classic version 5. And so if you want to get a copy and get a copy of this file that I'm using, and you can play with it yourself. But this is basically carrying on a conversation that somehow doesn't go away. And it's the idea that the CIT group is claiming that the flight that came into the Pentagon did not hit the Pentagon, but flew over. And so the flight, in order for it to appear to have hit, it would have to fly over the hole in the Pentagon. And they're claiming that it went north of the Citgo gas station, which is right here. In fact, that's labeled. All right. Right here are all these light poles. And so the real point of the CIT agenda that I can make out, I'm going to go ahead and use the terms that come naturally to me, and sorry about that, but it looks like they're trying to basically say it came in a suspicious direction that could not have done any of the damage. The external damage, the internal damage is all lined up along this path here, which is the path endorsed by the NTSB, and it's the path that agrees with the flight data recorder. It's the path of all the damage, and so there's a lot of evidence that contributes to this being the path of the incoming plane that actually hit the Pentagon and plowed through the outer three rings here, and making a small hole in the C ring right here. Okay, so the idea is if they could show that it came around this way, then what they've got is proof that all of this damage was faked. Okay, my take on that is it's absolutely, totally implausible to fake all of that damage. The amount of damage they're talking about is overwhelming. However, let's just take their flight path and look at it for plausibility. This is something that Frank Legg and I did back in 2011. We published 2 papers on it. One was on the website for Scholars for 9/11 Truth and Justice, and then there's a second one that was a follow-up to that in a different website. Anyway, so what I have here is an arc that we can play around with. And I've done a computation based on the curvature of this arc to translate the curvature of the path to what is the lateral acceleration. This is given by v squared over r, and then you have to convert the units to make them come out. All the units I'm showing over here on this side are in meters per second and that type of thing. So they're consistent units, and so g would be 9.8. Meters per second squared, for instance, and so forth. So what I'm going to do is let's take a starting point. Right down here in the left corner is where Ed Pike had his auto repair shop, and he basically testified that the plane came more or less overhead. He was sort of waving his hands around, a little bit hard to say exactly. It was a little bit to the south of him, but in this general area. There are questions, by the way, on whether he was actually outside where he could see it. It seems from later conversations that he was actually inside looking out through a window. So that would put the plane a little bit further south, probably. But whatever, we're not going to quibble about that. Let's just put the starting point of this arc down here, pretty much at his service station. And let's put this point up here somewhere, and this point here at where the hole is in the Pentagon. All right. So in order to get the curvature needed to go from Ed Pike's shop to a point north of Citgo, where these other people are saying it flew, and then not hitting, but flying over this hole, the curvature here is indicating a lateral acceleration of up around 5 Gs, 4.5 Gs, and a corresponding banking angle of about 77, 78 degrees. This kind of a banking angle was not observed. All of the observers had it flying. If they had a little bit of inclination to the plane, it was just very slight. Okay. However, if you go back and look at the actual video where Ed Pike does his interview, he actually draws a line that sort of goes like this across the Navy Annex. And so apparently whoever did this compilation of all these paths, I assume it's maybe Craig Ranke or whatever, I got this compiled onto a Google Earth thing from another source. It was just called 9/11 Maps or something like that. I'd have to look it up. But anyway, so, but they have it so he's going across here. And problem is, if you go in that direction, let's put this back at Ed Pike's place, and let's just go like that direction there. Whoops, we're going south of the Citgo station. So somehow you have to get north of Citgo. And even there you have about a 68-degree banking angle. And 2.5 Gs is way up there for a 757. But there you go. So this would be a high lateral acceleration and a very steep banking angle. This is not typical for flying. It would probably hold together at this angle, I'm guessing, but somebody with more aviation expertise could comment on that. But in any case, let's look at some of these others. If I just take sort of an average of all of these different witnesses and say, all right, let's take a curvature that's something like that. Notice again, we have banking angle 78 degrees. Here's 4.8 Gs. If I basically take the Ed Pike diversion thing here, that's 9 Gs, totally out of the realm of reality. Anyway, the bottom line is you can't just play around with just saying, oh, the plane turned. From Ed Pike's auto shop to the impact or the flyover, whichever you believe it happened, this is 5 seconds, just under 5 seconds. How do you get a plane to divert like that? Now, in the paper that Frank Legg and I did and published back in 2011, the acceleration was even greater because what we did was we took the plane as coming in along the official path until it diverted. There's the Ed Pike testimony. There's also another person, I forget his name right now, but it was along this edge of the Navy Annex somewhere. There's also Albert Hemphill, who was right about in here on this wing of the Navy Annex. So if you go from it coming in, like Craig Ranke asserts that, oh, he didn't say it was coming in on his right shoulder. It came in over his right shoulder as though it could go from there to the north of the Citgo somewhere and then over. That's an 80-degree bank angle. Okay, 6 Gs. That's not going to happen. All right, or if we even take it from here. So it's even more extreme if you assume that you have to take from this essentially straight on aiming at the Pentagon flight, which all the radar data indicates, and the flight data recorder both, and a lot of witnesses along this path. But if you take it curving left and then curving right, there's another element that comes in, which is you have to roll in order to get a left bank, a steep left bank like this, and then you have to roll and then get a steep right bank. And you can't roll from way left to way right. Maybe a fighter jet could roll over it in a couple of seconds, but you're not going to get a 757 to do that in under maybe 30 seconds or something. It's going to take a long time to go from a steep left bank to a steep right bank. And that kind of thing. These bank angles just don't happen, by the way. So anyway, bottom line is if you start just looking at it with just even some basic plausibility investigations like this, it looks like any kind of a path that's not going straight into the Pentagon from here, that's going to curve up and over and around, you're not looking at the implications. You're looking at high lateral Gs and high bank angles. This is like the angle of the tail from the vertical. or the angle of the wings from the horizon. Okay, so these are implausible, and bottom line is the CIT flight path does not represent reality in any way. You can't make it happen.